So what is centrifugal casting and what are the types of centrifugal castings? We'll see. See here we have centrifugal castings. In centrifugal casting, the three are there. That is true centrifugal castings, semi-centrifugal castings, and centrifuging. Okay. See the first. We'll see one by one. We'll see the topics. Okay. So last class we discussed the die castings. So they are also having a types of die castings. Okay. So in there is a four methods are there. Now here in centrifugal casting there is a three methods are there. So so one by one we see. So here we use centrifugal castings. Okay. So the casting is produced in a rotating mold. Okay. So it is a rotating mold. So the molten metal is poured in rotating mold. Okay. See here, the castings are produced by using a rotating mold. So the mold is rotated in motion. Okay. See the molten metal is also poured over the rotating mold. Okay. So while rotating, what happens? The mold rotates. Generally, this mold rotates at a speed of 1500 rpm. Okay. So there is a centrifugal force is created due to rotation. Okay. See here that molten metal spreads uniformly on the mold. So here while rotating that mold, so over the mold we can pour the molten metal. So here due to the centrifugal force, so the molten metal is spreads uniformly on the mold. Molten metal spreads uniformly on the molds. Okay. So when after mold pouring the mold, when it is solidified, the casting is removed. Okay. After solidification, the casting is removed. Okay. So impurities are pushed towards the center of the axis. So here the one advantages, what are the main advantages while rotating that mold? Okay. So pouring the molten metal, say this molten metal contains any impurities. Okay. That impurities are push towards the center point. Okay. So push towards the center points. Okay. It is suitable for the hollow products. Okay. It is suitable for cylindrical hollow products. Okay. These are the centrifugal castings. Okay. So here the centrifugal force will be created over the due to that so the molten metal spreads around the rotating mold. So here that molten metal contains any impurities. Okay. That impurities will be spread so towards the center point. Okay. So there from there we can going to remove it. So generally these things will be used in cylindrical hollow products. Cylindrical hollow product. Okay. So here this is about the centrifugal castings. So you will see the what are the advantages of this centrifugal castings. See here we have some advantages are there. What are the advantages of this centrifugal castings? Okay. So this centrifugal casting advantage, it is suitable for the all casting metals and as well as alloys. Okay. It is suitable for all casting metals like ferrous and non-ferrous metals, and also it is also suitable for alloys. Alloys means it is a combination of two or more metals. Okay. So there also it is suitable. Okay. So it is used for the large casting. So it is used for a large size castings. Okay. It is used for large castings. Okay. So the flywheels and hollow cylindrical castings, it is mainly used for flywheels and hollow cylindrical castings. Okay. So flywheels and as well as hollow cylindrical castings, a good mechanical properties of the product. Okay. So it has good mechanical properties can be arranged by using this centrifugal casting. So these are the advantages. So having a major advantage is that so it is used for both the metals. Okay. So casting the metals and as well as alloys. Okay. So generally these flywheels and hollow cylindrical castings can be produced by using this centrifugal castings. Okay. See these are the advantages are there. Say having the same having with disadvantages is there. So So what are the disadvantages? We will see here having a few disadvantages. So what are the disadvantages are having? It is not suitable for intricate casting. It is not suitable for intricate casting. Say high manufacturing cost. Okay, it is having high manufacturing cost. It is not suitable for intricate castings, and as well as high manufacturing cost. Okay, so that is the advantage and as well disadvantages. Okay, say here types of centrifugal castings. So here we have the few centrifugal castings are there, just earlier we discussed in the starting of this class. Okay, say here the first one is a true centrifugal casting, and second one is a semi-centrifugal casting, and last one is centrifuging. Okay, these are the three types of centrifugal castings. Okay, so the first one we'll see. So the true centrifugal castings. Okay, see what is the principle of this true centrifugal casting. Okay, see the molten metal is poured into a revolving mold. Okay, so here the mold is revolving. Okay, so the molten metal is poured into revolving mold. Okay, molten metal spreads towards the outer periphery of the well. Molten metal spreads towards the outer periphery of the mold. Okay, this occurs due to centrifugal force. This occurs due to centrifugal force. Okay, so after solidification the casting is removed. After solidification the casting is removed. It is a very small and also easy process, that is a centrifugal castings. Okay, so here the molten metal is poured a revolving mold. Okay, molten metal, how it's prepared means, see here we take the metal, so the metal will be melted in the separate furnace. Okay, so from there we can collect it in the ladle. Okay, from the ladle you can pour the molten metal into the revolving mold. Okay, so that is the process. Say here we have to observe the true centrifugal casting figure. Say here the rotation, there is the axis is there, there is a shaft is there, the shaft is rotated, so a complete mold is rotated. Okay, so here the ladle is there, so the ladle contains, so that is called crucible. So this crucible contains molten metal, so that molten metal is poured into the revolving mold. Okay, so revolving molds, so that is a centrifugal. So here we, if you pour like that, so that the mold is rotated. Okay, so that while rotating the centrifugal force is created, so that's created force, so the casting will be developed. Okay, so if you have any impurities, that impurities are pushed toward the axis of this mold. Okay, revolving mold, so that easily it will be removed from the centrifugal force. Okay, so that is about the centrifugal casting figure and the explanation. And the next one is the de Levant method is there. So this true centrifugal machine consisting, what is the machine having the parts. Okay, so that is the de Levant method. So the first one is a spinning mold. Okay, spinning mold, and second one is pouring through, and third one is a ladle, and the fourth one is a driving motor. Okay, and the fifth one is a sand core. Okay, say these parts you can able to observe it here in the figure, that is. Okay, spinning mold and pouring through, and third one is a ladle, the fourth one is driving motor. Say here a small difference is there. This is the third one is a ladle. Say here indicating a fourth. So just make correction, that is. Okay, see here how the process will be begins. Let's be discussed. Okay, see here and discussion point of view. See here this method consisting of a thin wall mold rotating about the axis. Thin wall mold rotating about the axis. This mold, the mold is rotated by driving motor. The mold is rotated by driving motor. So the ladle is used to pour the molten metal. The ladle is used to pour the molten metal. So the molten metal is poured into rotating mold. The molten metal is poured into rotating mold by means of through. So the by means of through, the molten metal is poured into the rotating mold by means of through. The through is one device by using that molten metal is poured. Okay, so TROUGS, please make a note, that is. So it is just like the pipes, so it is entry into the molten metal from ladle to mold. See here, this molten metal is poured into rotating by means of through. So due to centrifugal force, the molten metal passes the outer periphery of the mold. So it completely spreads over the mold, rotating mold. So after casting, after solidification, the casting is removed. So if you allow it to cool sometimes, so automatically the metal become cooled. Okay. So that is called solidification. Solidification is nothing but it comes from liquid stage to solid state. Okay, this process is called solidification. So here no core is required. Okay, the core is does not required. So the cast iron pipes produced by using this, the cast iron pipes are also produced. A 300 diameter and 6 meters long pipes are produced. 300 diameter and 6 meters long pipes are produced by using these methods. And the next one is next semi-centrifugal castings is a second type of centrifugal casting method. So here symmetrical castings like wheels are produced. Okay, in this method, so the wheels are produced. Okay, so mold is rotated at a speed of 350 rpm. This mold is rotated about a speed of 350 rpm. This molten metal is fed through a central sprue. A molten metal is fed through a central sprue. It spreads outward due to centrifugal force. It spreads outward due to centrifugal force. A dry sand core is used for getting central hole. A dry sand core is used for getting a central hole. Okay. So here the core is there. By using that core, we can going to produce a central hole. Okay. So dry sand core is used for getting a central hole. So this is symmetrical. So the figure is there. So here having the few parts, that is a cope and as well as dog. So in this one we can get the core. Okay, we used the core. We used to get the holes. So these strainers are there. Pouring basin is there. So by using that we can pour the molten metal. Okay. So with this we can get. Okay. So this mold will be rotated about 350 rpm. Okay. That is the semi-centrifugal castings. Okay. And the next one is centrifuging. Okay, so this centrifuging, the rotating mold consisting of a number of small molds. Okay, rotating mold consisting of a number of small molds. The molten metal is poured through central sprue. A molten metal is poured through a central sprue. Okay, so the molten metal is forced due to centrifugal force. A molten metal force due to centrifugal force. Dense castings are obtained. Dense casting are obtained. Intricate castings can be produced. So here by using centrifuging of casting, we can get the intricate castings can be produced. Okay, see here the rotating mold consisting of a number of small molds. Okay, see here the molten metal is poured through a central sprue. Okay, here we are going to attach one central sprue. From this central sprue we can pour the molten metal. Okay, so the molten force due to centrifugal. So if you pouring the rotating mold, so that will give some centrifugal force. Okay, so with this we can get some intricate castings. Okay, intricate means irregular castings. Okay, some irregular shape of objects also can be going to get by using this centrifuging by using a centrifugal force. Okay, so in this class we discussed about the centrifugal casting. So what is centrifugal casting, what are the advantages, and what is the application, what is the process discussed, and along with this what are the types of centrifugal casting. Say there is a 3 methods is there, so that is also discussed. Okay, true centrifugal casting, semi-centrifugal casting, and centrifuging. So in that one, what are the advantages, applications, where it is used. Okay, so all these things will be discussed so in this class. Okay, so we'll meet tomorrow again with a new topic. Okay, so thank you.